In this video, we're going to analyze a portion of the closed book, portion of the exam, um, and the analysis will be of some variation like this. You'll be given a V, you'll be given voltage, which is oscillation. Understand, this is a current oscillation, and it can be given a polar form, or I can give you this form, right? I can flip a few questions around, but generally it'll follow this format. So let me show you how to answer these questions, okay? And this is going to be very simple for you to understand, okay? And it'll require a little bit of analysis, but it's not really very difficult. You should have this down packed, okay? First of all, what is Vs in polar form? Polar form is analyzed by your magnitude and your angle, right? So 180 at, sorry, not 18, apologize here. 180 at angle 30 volts, okay? What is Is in polar form? Is in polar form is 2 at angle 45 amps. And now obviously this is going to be volts and amps. Okay, I apologize I didn't mean to apologize for not writing that initially. What is the frequency? Frequency is going to be 60 hertz, and we assume USA. When I ask you frequency, I mean in the country where you're at, okay? In third world countries, it's 50 degrees. We really don't need it unless you're traveling overseas, okay? Developing countries, third world areas are 50. It's the old British 50 hertz system, but the modern system is 60 hertz in America, Mexico, Canada, and so on and so forth. What is the angular frequency? Angular frequency is omega is 2 pi f. Anytime there's a pi or a 2 pi, it creates an angle. So 2 pi f is really omega at 2 times 3.14 times f, which is 60, right? And if you take out your calculator, okay, you will get 376.8, and your units is in radians. Okay, so radian unit. All right. What is V peak? So this is where this table is handy. One of the problems I had faced in engineering school was no one understood what all this meant, and this is very important. They kind of glossed over it, expected you to understand it. Peak is your met here, so V peak. So if you look at, let's analyze V peak really quickly, and so we will understand V peak. So we'll kind of take this side to side a little bit, right? And have two pieces of paper side to side, and I'll work two pieces of paper. So what we'll do is we'll draw the current, the voltage, and we'll draw the current, okay? And we're going to have this at, obviously, your voltage here, minus voltage here, current here, minus current here. Okay, so how does this look like? Your voltage looks like roughly 180. This is minus 180. This is going to be roughly 2. This is going to be roughly minus 2. Okay, so what is our peak? Our peak goes from here to here. That is our peak. Our current peak is from here to here. It's our current peak. Okay, I of P. It's an I. Pardon my handwriting, right? So our voltage peak is going to be 180 volts, just like here. Our current peak is going to be 2 amps, just like here. What is our max? Our max is our maximum value, V max. Our I max is our maximum value, I max, which is 180 volts and 2 amps. So our peak and our max are the same. Okay, what is peak to peak? Okay, let's study what's peak to peak. And what we want to do is kind of draw this a little bit here. Kind of go like this. Kind of, make the line kind of like this. Okay. And our peak to peak is peak to peak. Peak to peak. peak to peak. Okay, so this is 180 plus 180 is what? 360. That's 180 and 180 here. You add them together. What is our I peak to peak? This is 2, this is 2, so total is 4 amps. Okay, what is our RMS? What is our RMS? RMS is simply something that's labeled. Let me turn the lights on, make it easier to look at. Okay, RMS basically means our root mean squared, or 70%. So roughly here is the RMS. Roughly here is IRMS. Okay? So your RMS is going to be roughly 0.707, but we can say RMS is roughly 70% of our V peak. Your IRMS is roughly 70% of your I peak. Okay, and so this is going to be what? 180. So what's 70% of I-180? You take 0.7, you multiply by 180, you get what? So we're taking our calculator. Don't do this in your head. Okay, it's 180 times 0.7. You get 126, roughly 120 volts. Our I peak is 0.7 times 2. Is going to be what? So if you're confused, 0.7 times 2, 1.4 amps. So 1.4 amps. Okay. What is V measured or I measured? So when you read off a label, any label that you read off of, that's your measured. Okay. So when I see 120 measured from a voltmeter from a plug, that is your RMS. So when I'm measuring it, it's your RMS. So this is 126 volts. 1.4 amps is measured. So if I have any label of any circuit and labels, hey, this thing is output of 1.4 or input of 1.4, whatever it is, that's your RMS reading. Okay. Next page. What is the voltage phase? What is the phase voltage? I don't think we need this anymore. We can just move this out the way here real quick, right? And operate side by side. What is the phase voltage? Phase voltage is, what is the voltage phase? Phase is here. Phase and angle are the same thing. It's really your angle or your polar form. So your phase is going to be 30 degrees. Your current phase is what? It's the angle, 45 degrees. What is the power factor? Without the phase, you do not have the power factor. That's why I'm asking you these kind of questions. Your power factor is cosine of this minus this. So cosine of 30 degrees, which is the angle of V, or the angle of V, or the angle of V, minus the angle of I, which is angle of I, angle of I, angle of I. Notice they're the same thing, right? We use these different terminologies to mean the same thing. This is the cosine of minus 15. What is the cosine of minus 15? You take 15. Really is going to be a positive number, but you could take 15 minus, 15, and I take the cosine, and do this cosine, 15, okay, equals 0.965, or 0.967, right? So 0.967, so what is the efficiency? If I ask you the efficiency, I didn't ask you earlier, but what is the efficiency? Efficiency is basically 0.967 or 96.7%. That's where you get the efficiency of your electricity. Okay. What is your total power? Your total power is here's S. S is VI. Another video said VI over 2. You're going to ignore that for now. It's just, for us, it's VI. And it's going to be 180 times 2, which is 360 VA. If you do not have a VA, it's wrong. Okay? It's completely wrong. Okay? What is your complex power? Your complex power is another word for your VA, which is also 360 VA. Your parent power is the same as your complex power, which is the same as your total power, which is 360 VA. What is your real power? Your real power is your total power times the efficiency, or P is equal to VI times your power factor, which is what? 180 times 2 times 0.96. I'm running out of space. So what I'm going to do is I'm going to put the answer on this side here, okay? So I'll take 180 times 2 times 0.96. 345.6. 345.6 watts. What is the average power? Let me just go ahead and do this. Let's get that answer, right? What is the average power? Average power is the same as real power. 345.6 watts. What is active power? Active power is same as average power and real power. 345.6 watts. Okay?